In this video, we're going to take a closer look at calculated columns and measures in Power BI. We'll start with calculated columns because they tend to be more intuitive, especially for anyone coming from an Excel background. A calculated column is a new field added directly to a table. It's filled in row by row using a DAX formula, and you can use the results just like any other column in your data model. Calculated columns are great for creating new attributes, things like profit, full name, or category groups, that you can use for filtering, slicing, or grouping in your reports. Unlike measures, calculated columns are pre-calculated during data refresh and stored in the model. That means they're perfect for static, row-level logic, but not ideal for dynamic or aggregate calculations. Here are a few key characteristics of calculated columns. They reference entire tables or columns. They compute a new value for every row in the table. Their results appear directly in the data view. They're great for defining row-level properties, but not useful for aggregation. So the rule of thumb is, use calculated columns when you need to stamp fixed values onto each row of a table. But don't use calculated columns to perform aggregations or create numbers meant for the values area of a visual. That's what measures are for. Now let's talk about measures. Measures are also created using DAX, and they also reference tables and columns, but they behave very differently from calculated columns. Measures do not store values in your tables. Instead, they are calculated on the fly, based on the filter context of whatever visual they're used in. You can only see a measure's results inside a visual, like a card, chart, or matrix. A good analogy is an Excel pivot table. A measure works like a calculated field that only exists when you drop it into the values area. While calculated columns are evaluated using row context, measures are evaluated using filter context. The filters applied by the visual, slicers, and the user's selections. This means you should use measures whenever a single row can't answer the question, situations where you need to calculate totals, averages, year-to-date numbers, running totals, or any kind of aggregation. In short, measures are designed for dynamic, numerical calculations used in visuals. Now, how do you create calculated columns and measures? You have two options. 1. Use the Modeling tab and choose New Column or New Measure. 2. Right-click a table in the Data view or in the Fields pane and select New Column or New Measure. Both methods work, but there's one important difference. If you use the Modeling tab, Power BI will place your new measure or column in whichever table is currently selected, or sometimes the first table in the list by default. When I say a measure is assigned to a table, I simply mean it needs a home. It needs to live somewhere in the field list so that your model stays organized. So, for example, all sales-related measures might be stored in the orders table, while customer-related calculated columns might go in the dim customer table. Right-clicking on a table is usually the better approach because it lets you intentionally place your new field in the correct table, keeping your model clean and easy to navigate. That's the approach I recommend and the one you'll see me using throughout this tutorial. Now let's jump into our Power BI file and walk through a quick demo. The first thing we're going to create is a calculated column. To do that, we simply right-click the table in the Data view, or the table name in the Fields pane, and choose New Column. For this demo, we'll name the new column line Total Sale, and it will be equal to shipped quantity multiplied by unit retail. Right away you'll notice that IntelliSense starts helping us as we type. This feature is incredibly useful. It not only speeds up writing DAX expressions but also hints at what's valid in the current context. One thing I've learned over the years, if IntelliSense doesn't let you select something you think should be available, it usually means the formula is wrong or the context isn't appropriate. IntelliSense is pretty smart. So here I'll select orders, shipped quantity, and orders unit price, both from the orders table, which is the table we're currently working in. That gives us the expression Line total sale equal to orders, shipped quantity, multiplied by orders, unit price. When I press enter, Power BI creates a brand new column. And if we scroll, we can see that this calculation was applied row by row, multiplying quantity and price for each order. This is a perfect example of when a calculated column makes sense. Now let's look at an example of what not to do with calculated columns. Suppose we create another new column and call it total quantity, and this time we use an aggregation like sum orders shipped quantity. If we hit enter, you'll see that every row shows the exact same number, 8,202,465, because it's returning the grand total of the entire column. This gives us a duplicated value on every row, which is meaningless. This is not a valid use of a calculated column. So let's delete it. For this type of calculation, we should be using a DAX measure, and that's what we'll create next. To create a measure, I'll right-click on the orders table and select New Measure. Power BI now knows we're creating a measure, not a column. Let's name this measure Total Sales, and we'll set it equal to Sum Orders, line Total Sale. After we press enter, you'll see the measure appear in the fields pane with a little calculator icon next to it. But if we look at the table itself, there's nothing new there, and that's important to understand. Measures don't show up as data columns. What we've created is simply a stored calculation that Power BI will evaluate when we use it in a visual. Let's quickly demonstrate what that looks like. I'll switch over to the report view and drag the total sales measure into the canvas. Power BI generates a clustered column chart by default. I'll change the chart to a table, or matrix, and now we can see our total sales value. Next, I'll drag the order date year field into the visual. And now we can see total sales broken out by year, along with the grand total. This illustrates one of the biggest advantages of measures. They're calculated at runtime, based on the current filter context, the filters applied by visuals, slicers, or user selections. That dynamic behavior is what makes measures so powerful and flexible. Now, on the right side of the home ribbon, you'll see an option called New Quick Measure. When you click it, a large dialog box appears with several built-in calculation types. There are 6 groups: aggregates per category, filters, time intelligence, totals, mathematical operations, and text. Let's build a quick measure together. I'm going to choose running total under the totals category. For the base value, I'll go to the orders table and select the total sales measure. Next, it asks for a date field, so I'll again go to the orders table and select order date. For the direction, I'll choose ascending. When I click Add, Power BI automatically creates a new measure in the orders table called Total Sales running total and order date. Let's click on that measure to examine the DAX. Power BI generated a fairly sophisticated expression. It recalculates total sales using Calculate, removes row-level filters from order date using All Selected, and uses Filter plus is on or after to include all dates up to the current row, exactly what a running total needs. The best part is, we didn't have to write any of this manually. Now let's use it in a visual. I'll drag total sales running total and order date onto the canvas. For the x-axis, I'll use order date from the orders table. In a table or matrix, you'll see total sales accumulating day by day. Quick measures make it incredibly fast to generate these kinds of calculations, even though the underlying DAX is quite advanced. Quick recap: calculated columns versus measures. Calculated columns evaluate row by row inside the table. They store values physically, increasing your model size. They refresh only when the data source refreshes or when their dependent columns change. Measures evaluate dynamically based on filter context in the report. They do not store data, so they don't go your file. They recalculate instantly whenever user slices, filters, or interacts with the report. calculated columns are mainly used as dimensions, for rows, slicers, filters, and grouping. Measures are primarily used in the values area of visuals. That wraps up today's lesson. In the next video, we'll explore some of the most commonly used DAX functions in Power BI. Thanks for watching, and don't forget to subscribe to support the channel and stay updated on upcoming lessons.